Okay, so in this video we are going to discuss on how to add and subtract rational algebraic expressions. So we are going to perform addition and subtraction of rational algebraic expressions, and of course on how to reduce our answers to lowest terms. So in our previous video, I've already discussed on how to find the least common multiple, or the LCM, or the least common denominator, or the LCD. So I think you are ready for our next discussion. So let's start with our number one problem. We have x over 3 minus y over 3. So observe that the two rational expressions are similar rational expressions, meaning they have the same denominator. And the rule in adding similar rational algebraic expressions, we simply subtract or add the numerators and copy the common denominator. So we have x minus y all over the common denominator 3. Since there is no common factor and we cannot reduce this to lowest term any further, therefore this is now the final answer. Okay, and let's have our example number 2. We have 9ab over cd squared minus 7ab over cd squared. Just like our previous example, this is also a similar rational algebraic expressions. So we will apply the same rule or process. So subtract the numerators and copy the common denominator. So we have 9ab minus 7ab. So we have 9ab minus 7ab all over the common denominator, which is cd squared. Okay, or you can do that directly. Subtract 9ab minus 7ab outright. So 9ab minus 7ab, similar terms. So that means subtract the numerical coefficients, 9 minus 7, so we have 2, and just copy the common literal coefficients over cd squared. And then observe if there are common variables that can be cancelled out. But in this case, there is no common variable, therefore this is now our final answer. We have 2ab over cd squared. Okay, so for our next example, let us make some space for our next example. So let's have 10 over x minus 3 minus 2x plus 9 all over x minus 3 plus, in this case we have 3 rational algebraic expressions that need to be subtracted and added. And the third one, we have 5x minus 7 all over x minus 3. So again, we have similar rational algebraic expression since we have common denominator, which is x minus 3. So what we are going to do is simply add or subtract the 3 numerators and simply copy the common denominator, which is x minus 3. So we have 10 minus, since there are 2 terms followed by preceded by rather the subtraction sign, so we need to enclose this in parentheses, 2x plus 9 and then plus 5x minus 7. So if you have noticed, we did not actually put 5x minus 7 in parentheses since this won't affect actually the signs of the terms since we have addition. It only affects the sign within the quantities if we have subtraction here, and that's very important. All over the common denominator, which is x minus 3. Then we're going to simplify the numerator. So we have 10 and distribute the negative sign here. So we have negative times 2x. So we have negative 2x. Negative times positive 9. So we have minus 9 plus 5x minus 7. All over x minus 3. And simplify further by combining like terms. So let's combine first all the numbers. So we have 10 minus 9. So we have 1. 10 minus 9 is 1. Minus 7. So we have 10 minus 9 minus 7. All the numerical terms. So 10 minus 9, or we can 10 minus 9 is negative 1 minus 7, and then negative 1 minus 7 is negative 8. Okay. So adding the same sign or subtracting the same sign, that means we only need to add the numbers and prefix their common sign. So negative 8. So we have negative 8 and then negative 2x plus 5x. So we have negative 2x plus 5x. That means negative 2 plus 5. So we have positive 3 and copy x all over x minus 3. Okay, or we can write this as, since we have positive term here, we can write this first, 3x minus 8 all over x minus 3. And let's see if we can simplify this further. So there is no common factor between 3 and 8. And same with x minus 3. Both are prime polynomials. Therefore, this is now the final answer. Okay. Next. Let's make some new space again. So let us have as many examples as we can so that you will have a better understanding on how to add and subtract rational algebraic expressions. Okay, so this time let's have a dissimilar rational algebraic expression so that we can apply the concept of LCM or LCD. So let's start with x, a basic one, x plus 1 all over 2 minus x minus 2 all over 3 plus 2x minus 1 all over 9. So we have now 3 different denominators, namely we have 2, 3, and 9. So before we can add these 3 different rational expressions or dissimilar rational expressions, we need to find first the LCD of 2, 3, and 9. And we can use the method I've taught you earlier in our previous video by continuously dividing the number by their common prime factors. So we have 2, 3, and 9. So 2 is already prime, but 3 and 9 have common factors. And 3 and 9 are both divisible by prime number 3. So since 2 cannot be divided by 3, so bring it down, 2, just copy. And then 3 divided by 3, we have 1. 9 divided by 3, we have 3. Okay? And observe that the numbers below are all prime numbers. So we can now multiply the numbers here. So we have 3 times 2, we have 6 times 1, 6 times 3, we have 18. Therefore, the GCF, or I mean the LCD here is 18. Okay? So you have to take note that the LCD cannot be lower than the highest number here. Okay? Because our goal here is to divide exactly the numbers in the denominator. If it is lower than the highest number, so how can we divide 9 exactly without any remainder? Okay? So you need to remember that the LCD should be equal or higher than the highest number in the denominator. Okay? So what are we going to do next after finding the LCD? So what we are going to do is to multiply all rational expressions by our LCD. So we're going to write the LCD here outside our brackets and multiply each rational expression one by one. So that means we have 18 times x plus 1 over 2. But we can directly cancel out the common factor. That means 18 divided by 2. So 18 divided by 2, this will be cancelled out, and we have a remaining factor here, 9. And this remaining factor will be multiplied to x plus 1. So therefore, we have 9 times the quantity x plus 1. Okay? Or you may write this as x plus 1 over 2 times 18 minus x minus 2 over 3 times 18 again plus 2x minus 1 all over 9 times 18. So any method you are comfortable using. But in my case, it is convenient for me to simply multiply the LCD or to put the LCD here and then multiply it directly to each rational algebraic expressions. And anyway, as long as the process is correct, you will arrive at the same answer. Okay, so let us not erase this first. So let's move on. Next is, let's erase this first. Okay. Then 18, next is minus. 18 times x minus 2 all over 3. So that means 18 divided by 3, this will be cancelled out. Remaining factor is 6. So we have 6 times negative here, so we have negative 6 times the quantity x minus 2. So take note, this is subtraction, and the following terms is a binomial term, so we need to enclose this in parentheses. And then plus. Okay? So we only need to remember that every time we multiply the LCD to each rational algebraic expression, it should be the original LCD. Okay? Not the remaining factor. So 18 times 2x minus 1 over 9, all over 9. So that means 18 divided by 9, this will be cancelled. Remaining factor is 2. And then 2 times the quantity 2x plus 1. So 2 times the quantity 2x minus 1 rather. Okay. So almost the same here. So the remaining factor is 9. So 9 times x plus 1 here, the quantity x plus 1. And 18 divided by 3, so we have 6. So 6 times here, we have negative 6 times the quantity x plus 2. And then 18 divided by 9, remaining factor is 2. And then 2 times the quantity 2x minus 1. Okay, that's it. And of course, all over the LCD, which is 18. And let's simplify this further. The numerator. So distribute 9 inside the quantity. So 9 times x and then 9 times 1. 9 times x, we have 9x. And plus 9 times 1, we have 9. Negative 6 times x, we have negative 6x. Negative 6 times negative 2, so we have positive 12. Plus 2 times 2x, we have 4x. And 2 times negative 1, we have negative 2. All over 18. Then simplify by combining like terms. So 9x minus 6x. So 9x minus 6x. Let's do it this way. So we have 3x and then plus 4x. So we have 7x. So we have 7x and the constants, we have 9 plus 12, or we can have 12 plus 9. So we have 21. And then minus 2. So we have here, this becomes 11. So 9. So we have 19. So plus 19 all over 18. Okay? Then let's observe if the numerator and the denominator can be factored out, or there is a common factor. So 7x and 19, so there is no common factor. Same with in the denominator, which is 18. So therefore, this is now the final answer. So always box in your final answer. Okay? That's it. And let's proceed to our next example. Okay. And our next example is 3 over a minus b plus 4 over a plus 2b. Let's observe that the two rational algebraic expressions are dissimilar, meaning they do have different denominators. The first one here we have a minus b, and the second one here we have a plus 2b. Okay? The question now is, are the two polynomials factorable? Let's find out. So in here we have a minus b. There is no common factor here, or this is no longer factorable. That means this is already a prime polynomial. And we have a plus 2b. There is no common factor between a and 2b. So this is another prime polynomial. In this case, if the denominators are both prime to each other, so meaning they don't have any common factor at all, we simply multiply the denominators. Okay? Just like 2 and 3. Both are prime numbers, so meaning we are going to multiply 2 times 3, so the LCD is 6. Okay? However, in this case, these are not numbers. These are expressions. Okay? And as I've said last time, we are not going to multiply the factors. We are going to leave it as it is, meaning in factored form. So the LCD is, let's write the LCD here on the right side. In factored form, we have all our distinct factors, meaning we are going to get all the factors. The quantity a minus b times the quantity a plus 2b. Then multiply each rational algebraic expression by this LCD. So the LCD times 3 over a minus b. Okay, so of course this will be cancelled out, and the remaining factor is the quantity a plus 2b times 3. So we have 3 times the quantity a plus 2b, and plus, again, the LCD times 4 over a plus 2b, and this will be cancelled out, and the remaining factor is the quantity a minus b times 4. So we have 4 times the quantity a minus b all over the LCD, which is the quantity a minus b times the quantity a plus 2b. Okay, then simplify by distributing 3 inside the quantity and distributing 4 inside the quantity here. So we have 3 times a, so we have 3a plus 3 times 2b, so we have 6b plus 4 times a, we have 4a And 4 times negative b, so we have negative 4b. All over the LCD again, so just copy quantity a minus b times the quantity a plus 2b. Next, simplify further by combining like terms. We have 3a here and 4a, so we have 7a. 6b minus 4b, so we have 2b times the all over, the quantity a minus b times the quantity a plus 2b. Then let us observe if there are common factors, or the numerators and the numerator and the denominator are still factorable. But in this case, 7a plus 2b, there is no common factor. So prime polynomial or prime, yes, and there is no common factor in the denominator. So therefore, this is now our final answer. That's it. Okay. Next example, let's have a over 4a plus 1 plus 2 over 4a squared minus 7a minus 2. So this next example we have is a little bit complicated than our previous examples, but just listen carefully. Okay, so the denominators are 4a plus 1, and obviously this cannot be factored anymore. So let's move on to our next denominator, which is 4a squared minus 7a minus 2. So this is again a general trinomial, general quadratic trinomial to be exact. So in this case, 4a squared minus 7a minus 2. So obviously, let's make two empty quantities here for the binomial factors. The first term is 4a squared. So this is a perfect squared term, or perfect square. So that means the first terms are both 2a, and we have here 2a, right? Then the last term is negative. That means one of the factors is negative, because positive times negative is negative. And the middle term here is negative, meaning the bigger number is negative. So what we are going to do here is multiply. If we have a numerical coefficient here greater than 1, so we are going to multiply 4a squared minus 7a minus 2. Multiply this. So 4 times negative 2 is negative 8. Okay? So negative 8 meaning one of the factors is negative, and we are looking for factors of 8 that when added is 7. Here, the middle term. So if we're going to list down all the possible factors of 8, we only have 1 times 8, and we have 2 times 4. So between these possible factors, we are looking for possible factors of 8 that when added is negative 7. So you have to take note that the last term is negative, meaning one of the factors is negative. And the sign of the middle term here gives us clue that the bigger number is negative. So between 1 and 8, the bigger number is 8. So therefore, this is negative and 1 is positive. Here, between 2 and 4, 4 is bigger than 2, so this is negative and this is positive. But which of the two possible factors here will give us negative 7? So obviously we have 1 minus 8, we have negative 7. So in no instance that this will be equal to negative 7. So because negative 4 plus 2 or 2 minus 4 is negative 2. So therefore, this is automatically discarded. So the possible factors here is, the possible factors are 1 and negative 8. So since 1 is positive, so we have plus 1, and this is minus 8. Okay? Hopefully you are following. Then, let's copy here. No. Let's copy 4. Here. 4. Okay. For whatever the numerical coefficient here, just copy it here. Okay? And then, divide it by whatever number we have here. 4. Then, let's simplify further. There is no common factor between 4a plus 1, so just copy 4a plus 1. And 4a minus 8, there is a common factor 4. Then 4a divided by 4, we have a. And negative 8 divided by 4, we have negative 2 all over 4. And this will be cancelled out. Okay? That means we have now 4a plus 1 times the quantity a minus 2. So, these are now the factors of this one. So, you can check this by multiplying it back. If we will arrive at 4a squared minus 7a minus 2. So, it's all up to you to check whether the factors are correct, but this is correct. That's only for your benefit. So we have 4a plus 1, and we have the quantity 4a plus 1 times the quantity a minus 2. So it is very important that we are going to write this in factored form. We have a over 4a plus 1 plus 2 over the quantity 4a plus 1 times the quantity a minus 2. Okay, so let's look at the denominators. So 4a plus 1 is common to both denominators, and the degree of exponent is the same. So we have 1 here, we have 1 here. So since 4a plus 1 is a common factor and they have the same degree, just get 1, 4a plus 1. And we have another distinct factor which is a minus 2. So recall that every distinct factor should be part of your LCD. So therefore the LCD is the quantity 4a plus 1 times the quantity a minus 2. Okay? Then, let's proceed. Multiply each rational algebraic expressions by our LCD. So the LCD times a over 4a plus 1, this will be cancelled. 4a plus 1 will be cancelled. So we have remaining factor, the quantity a minus 2 times a. So we have a times the quantity a minus 2 plus. Next, our LCD times 2 over the quantity 4a plus 1 times the quantity a minus 2. So all the factors here will be cancelled, meaning this becomes 1. Take note that when the factors are cancelled, it becomes 1. Okay? So 4a plus 1 will be cancelled. A minus 2 will be cancelled, meaning this becomes 1 and 1. And we have 1 times 2, so we have 2. All over the LCD, 4a plus 1 times the quantity a minus 2. Then, simplify further. We have a times a, we have a squared. A times negative 2, we have negative 2a plus 2 all over 4a plus 1 times the quantity a minus 2. And let's see if a squared minus 2a plus 2 can be factored, so that if there's any common factor in the denominator, then we can simplify it further. So let's see. We have a squared, that means a and a, and factors of 2, we only have one possible factor, 1 times 2. And the last term is positive, meaning both are negative here. So when added, we have negative 3. It will never be equal to negative 2, meaning this is no longer factorable. So, this is now our final answer. A squared minus 2a plus 2 all over the quantity 4a plus 1 times the quantity a minus 2. That's it. And let's have another example. So let's cover as many examples as we could, so that you will have a better understanding on how to add and subtract rational algebraic expressions, most especially about dissimilar rational algebraic expressions or finding the LCD. Because the key in adding and subtracting rational algebraic expressions lies on your skill in determining or finding the LCD first. If you messed up with or finding LCD, then everything is wrong. So we have 2x over 2x squared plus 5x minus 3 plus 5 all over x squared minus 9. Okay, so first and foremost, factor out the denominators as completely as possible. So we have 2x over. So this is similar to our previous example earlier, where the numerical coefficient is greater than 1. So we have 2x squared plus 5x minus 3. So multiply this to 2 times negative 3 is negative 6. So that means one of the factors is negative. And look at the middle term, it's positive, meaning the bigger number is positive. Okay, and let us make two empty quantities. So let's copy 2x and 2x here. Then let us find factors of negative 6 that when added is positive 5. And there are only two possible factors, 1 times 6 and 2 times 3. So the middle term is positive, meaning the bigger number is negative. The bigger number is positive, I mean. Again, the bigger number is positive, meaning the bigger number is positive here. So this means this is negative and this is negative. So which of the two factors that when added will give us positive 5? So obviously, we have this one. Negative 1 plus 6 will give us positive 5. So therefore, we have 2x plus 6 and 2x minus 1. Okay? Then whatever first term we have here, or numerical coefficient here, over 2. And look at the numerators. If we have common factor, 2x plus 6, so common factor 2, remove that. So x plus 3 and 2x minus 1 is no longer factorable. All over 2. Cancel this out. So we have here the quantity x plus 3 times the quantity 2x minus 1. That's it. Okay. Next, we have x squared minus 9. Again, this is sum and difference of two terms. So x squared minus 9, it follows the format of a plus b, and we have a minus b. So we have here x squared, so we have x. So this is quite easy. And the square root of 9 is 3, so that means plus 3 and minus 3. Okay? So done factoring our denominators. And the next step is to find now the LCD. So the LCD, okay, x plus 3 is common to both denominators. And they have the same degree. So therefore, just get x plus 3. And there are two distinct factors. We have the quantity 2x minus 1 and the quantity x minus 3. So we are going to get the two distinct factors, 2x minus 1 times the quantity x minus 3. Okay, so I think this will be a little bit lengthy, so just bear with me. Okay, next, multiply each rational expression to our LCD. So 2x over the quantity x plus 3 times the quantity 2x minus 1 times our LCD. So let's look at factors that will be cancelled out. So we have x plus 3 here will be cancelled out, and 2x minus 1 will be cancelled out. So the remaining factor is x minus 3 times 2x. So we're going to write 2x times the quantity x minus 3. And then plus this rational expression times the LCD. So look at factors that will be cancelled. X plus 3 will be cancelled here, and x minus 3 will be cancelled out. So the remaining factor is the quantity 2x minus 1 times 5. So we have 5 times the quantity 2x minus 1 all over the LCD. Quantity x plus 3 times the quantity 2x minus 1 times the quantity x minus 3. Simplifying further, multiply 2x times x, we have 2x squared, and 2x times negative 3, we have negative 6x, and 5 times 2x, so we have 10x, and 5 times negative 1 is negative 5, and copy the denominator. Okay, that's it. Simplify further. Let's put an arrow here. So 2x squared, negative 6x plus 10x, we have 4x minus 5. All over, we have x plus 3 times the quantity 2x minus 1 times the quantity x minus 3. Okay? So is the numerator still factorable? So we have 2 and negative 5. We have negative 10. Factors of 10 that when added is 4. We only have two possible factors, 1 and 10, and 2 and 5. Okay. So negative 5, meaning one of the factors is negative, the middle term is positive, that means the bigger number is positive. So negative 1 plus 10 is 9. It will never be 4. Negative 2 plus 5 is 3. It will never be 4. So therefore, this is now the final answer. Okay? That's it. Next one we have the last one maybe. We have 2x over x squared minus 2x minus 15 minus x minus 2 all over 3x squared plus 9x. Okay, that's it. So 2x. Factor out the denominators as completely as possible. So this is quite easy. So first terms, x. So we only have two possible factors of 15. We have 1 times 15 and 3 times 15. But we are looking for factors that when added is negative 2. The fact that it is negative, that means one of the factors here is negative and the middle term is negative, meaning the bigger number is negative. This is 5. So if this is negative, automatically we have 1 minus 15 is negative 14. So automatically this is wrong. And if this is negative, so we have 3 minus 5, we have negative 2. So the two possible factors are plus 3 and minus 5. Then x minus 2. Next is 3x squared plus 9x. So 3 and 9, both divisible by 3, 1 and 3. So 3 times 1 is 3 times 3, 9. So that means, the GCF is 3. So 3x squared plus 9x. So the greatest common factor is 3, and then they both have x. So since we are looking for GCF, in factoring we use the GCF. Okay? So get the least. X squared and then x, so we have x. Then 3x squared divided by 3x, so we have x. And then 9x divided by 3x, so we have 3. That's it. Then so let's start with the outside factor first, which is 3x. So this is only 1. So that means this is a distinct factor. So automatically we will have 3x. And x plus 3 is common to both denominators and same degree. So x plus 3. And we have a distinct factor, x minus 5. So that means the LCD is 3x times the quantity x plus 3 times the quantity x minus 5. And multiply each rational algebraic expression, okay, to our LCD. So 2x over the quantity x plus 3 times the quantity x minus 5 times our LCD. So let's look at possible factors, common factors that will be cancelled out. So x plus 3 here will be cancelled out, x minus 5 will be cancelled out. Remaining factor is 3x times 2x. So we have 6x minus x minus 2 times the over 3x times the quantity x plus 3 times our LCD. So 3x will be cancelled here, same with x plus 3. The remaining factor is x minus 5 times the quantity x plus 2. So we have the quantity x minus 2 times the quantity x minus 5. all over the LCD 3x times the quantity x plus 3 times the quantity x minus 5. Simplifying further, we have 6x minus, so let's simplify the two quantities here first. We have x minus 2 times the quantity x minus 5. So let's use FOIL method. Multiply the first terms. So we have x squared. The outer terms, x times negative 5 is negative 5x. The inner terms, negative 2 times x is negative 2x. And the last terms, negative 2 times negative 5 is positive 10. So therefore, we have x squared negative 5x minus 2x is negative 7x plus 10 all over 3x times the quantity x plus 3 times the quantity x minus 5. Okay? And let's solve here. Simplify further. We have 6x. So to remove the parentheses here, distribute the negative sign. So negative times x squared, so we have negative x squared. Negative times negative 7x, we have positive 7x. Negative times 10, so we have negative 10. All over 3x times the quantity x plus 3 times the quantity x minus 5. And simplify further again by combining like terms. So we have negative x squared, 6x and 7x. So we have 13x minus 10. Okay? All over 3x times the quantity x plus 3 times the quantity x minus 5. Okay? So, there are no possible factors of 10 that when added is 13. We have 1 times 10 and we have 2 times 5. So, in no case that the two possible factors will add up to 13x. So, therefore, this is no longer factorable. The leading term is negative. Okay. However, if there is a possibility that this is positive, we can write this first. However, this is also negative. So, we can leave it as it is. Negative x squared plus 13x minus 10 all over 3x times the quantity x plus 3 times the quantity x minus 5. So if you have noticed, in our final answers, it is no longer reducible to lowest terms. Okay, but take note that we tried to factor out as possible if we still have, if there is still a common factor to be cancelled out, but it so happened that it is already in lowest terms. Okay, but you have to take note that every time you arrive at your final answer, make sure that there is no common factor between your numerator and denominator, so that we can make sure that it is already in its lowest terms or simplified form. Okay, that's it. So we will stop here, and maybe we could have another video for adding and subtracting rational algebraic expressions for more example.